Ladies and gentlemen, hello and welcome, coming to you once again, not quite live, from One Take Studios, where today we are talking about solving rational equations. Okay, what words did you just see/hear? Solving rational equations. What do these words mean? All words have meanings. Rational, again, is ratio, so we're talking fractions. But the other key word here, believe it or not, is equations. There are a shocking number of people on this planet that are mentally unobservant. I don't really blame them. It's hard to be mentally observant. But if you can teach yourself to watch for details, you will stand out big time. And since the videos leading up to this have all been about rational expressions, this word right here means we need a major shift in our mindset for how to approach these problems. All right, so how do we decide if something's an equation versus an expression? Dun, dun, dun. Guys, you gotta have equal signs, all right? If you see an equal sign, it is an equation. If you do not see an equal sign, it is not an equation. It's an expression, and that means an entirely different approach to things. As simple as that sounds, you've got to look for it. It's not going to announce itself. All right, now two essential approaches we want to see for these things today, one of which is relatively straightforward, but I kind of shudder to use it just because the words cross multiply mean so many things to so many people and so many wrong things to so many people. But in the event, and I'm going to lay this out for you, that you have one fraction equals one fraction. So say conditional sentence, if one fraction equals one fraction, then you can cross multiply. That's the only circumstances under which you should be cross-multiplying. Everything else, you really shouldn't be cross-multiplying. Now, what might this look like? Let's check out an example. I've got this guy right here. 5x over x minus 2 equals 3x minus 4 over x minus 2. Again, it's rational. We can see our fractions here. It's an equation. We can see the equal sign. Because it is one fraction equaling one fraction, we can cross-multiply. Some of you might see something else right here and now. I don't blame you. Hold that thought. I've got a purpose to this. I'm going to come back to it, okay? But what I am going to do is cross-multiply, which means, oh, here we go. Think Valentine's Day. This one goes here. So we multiply this one times this one, and then this one goes here, this one times this one. Oh, look, it's a heart. So, if I do x minus 2 following this side of the heart, x minus 2 times 5x, that is 5x times x minus 2. I know, crazy, huh? X minus 2 times 3x minus 4, following the other side of my heart here. X minus 2, parentheses, are important, times 3x minus 4. What am I going to put in the middle of this? Here's the other thing about cross-multiplying. It's very abstract to people. They have no idea what goes here. This needs to be an equal sign. If these ratios are true, that means multiplying one way needs to be equal to the value multiplied the other way. Really quick check off to the side. Let's say I've got 1/2 is equal to 3/6. Most people know that to be true. Well, think about what happens if I multiply one way. 1 times 6 is 6. If I multiply 2 times 3 the other direction, 2 times 3 is 6, and 6 equals 6. So what we're seeing here is what we are doing here, but with a whole bunch more letters and fun stuff. So multiplying one direction, coming across, multiply the other direction, equal sign between them. There we go. Okay, so I think that we need to do some multiplication, shall we? That's going to be 5x squared if I distribute minus 10x, and then I need to FOIL stuff. So 3x squared, that's going to be minus 4x minus 6x, so minus 10x, unless I'm making a mistake, plus 8. No, I'm not going to write out all of the foiling things that just happened. Yes, I combined like terms. Feel free to catch up. Pause. Go for it. All right, I'm going to set this equal to 0 because I'm solving a quadratic, and 9 times out of 10, if I'm solving a quadratic, setting it equal to 0 is helpful. I'm going to subtract the 3x squared. That's going to give me a 2x squared over here. I'm going to, oh, that's weird, add 10x and add 10x. Wait a minute. Those are just going to drop. That's fascinating. Gone. You know what? I'm going to leave that there for a second. Equals, I'm going to keep this 8. There we go. So I subtracted 3x squared. My 10x's on each side canceled out because if I add 10x, gone. You know what? I've just decided I don't want to set this equal to 0 anymore. Why? Because I only have one x, which means I'm going to let my natural instinct for solving kick in, and I'm just going to get the x by itself. I can do that, right? Sure, of course I can. So let's see here. What's going to happen with that? We're going to talk about, dividing by 2, that's gone. Now I've got x squared equals 4. And, oh yeah, I'm just going to take the square root, right? Yeah, cool. There we go. X equals 2. Or does it? Dun, 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 dun. How's your brain doing? Are you thinking? Did I mess something up? Oh, today is not the day, is it? Today is just not the day. Checking. -4, -6, -10. I think I wrote something down wrong. I did write something down wrong. Alright, we're going to go with this then, because this is what I have in my paper. Never mind. Alright, now, some of you hopefully are yelling at me going, hey, wait a minute, this is quadratic, shouldn't there be two answers? Yes, there should be two answers. So this should actually be plus or minus, because when I take a square root, it could be +2, it could be -2, either way. So my answers are 2 and -2. Or are they? We have denominators. We've been talking all along with our expression stuff about where the expressions might be undefined. We have learned that we cannot divide by 0. Dividing by 0 opens a wormhole and swallows the world. So, if this were to be 0, I would have a problem. That means that if x is 2, I have a problem. X can't be 2. So if I think about these guys separate from each other, I've got a 2 and I've got a -2 here. It can't be 2. 2 does not work. Bonus points if you remember what that word is. That is called an extraneous solution. Extraneous. In other words, we didn't do anything wrong. We just have an extra number that worked as part of the solving process, but doesn't work in the equation when you go back to it. All right, so +2 is extraneous. We're getting rid of it. We're keeping the -2 and calling it good. Okay. All right, cool. Now, I do want to go back to something I referenced earlier that some of you might be seeing something else here. Humor me for a moment. We talked about something a while back with solving exponential equations and logarithmic equations, the idea of equating sides. If the left side is really equal to the right side, well, then there's a couple things that have to be true. In this case, x minus 2 is already equal to x minus 2. That part's already the same. Therefore, by logic, the numerators must also be equal. That means that 5x from the left would have to equal 3x minus 4 on the right, because otherwise this couldn't be true. So let's just think about solving this for a second, ignoring the denominators because they're already the same. I'm going to subtract 3x from both sides, call that 2x equals -4, and divide, and x equals, well, what do you know? There we go. I get the exact same thing. What's the difference? I didn't get the extraneous solution this time. That's okay. It wasn't really a solution anyways. I've got the one solution that mattered. That worked. So if your denominators are already the same, you can set the numerators equal to each other. I'm just saying this is not going to happen frequently, probably. This is more likely what you're going to see. So if a fraction equals a fraction, boom, cross multiply, make it happen. Pay attention for extraneous solutions, all right? Okay, so that is, I guess, on the easier side of things, sort of, kind of, maybe, I don't know. All right, so other thing that we've got here next, what happens if we don't have one fraction equal to another fraction? This is my advice for you today. If we don't have a fraction equals to a fraction, if it's more complicated than that, otherwise we're going to destroy the denominators. Dun dun dun! That is today's goal for the rest of this video, is to destroy denominators. How do we make that happen, you ask? I'm so glad you asked. We can destroy denominators by multiplying by the least common denominator. If you've been working with fractions and working with adding and subtracting and getting least common denominators, that skill's about to come in handy. Why is this a legitimate strategy? Are you listening to me? The only reason this works is because we have equations today. You cannot do this with expressions. You think I meant that? Yes, you may only use this strategy with equations. This does not work with expressions. It's illegal with expressions. Let me show you why. All right, so example 1. Notice I have this example for this equation really spread out, and there is a purpose to that. So if you're writing, you may want to leave yourself a couple of gaps as well. I have 6 over x plus 5 over 4 equals -7/4. Great. If I look at my denominators, I have an x and a 4 and a 4. What do you think my least common denominator might be? Well, let's see. We said for doing this, we want to take the highest power of every factor. So x is a factor, highest power of 1. 4 is a factor. Technically, that's 2 squared. That's also 2 squared. So 2 squared or 4 is also going to be a factor. So ladies and gentlemen, again, we want every factor represented. My least common denominator here is going to be 4x, because that's going to encompass all the factors that I see here in my denominators. So I'm going to multiply by the common denominator. I'm going to multiply this by 4x. I'm going to multiply this term by 4x. I'm going to multiply this term by 4x. Why can I do this? Because of the equal sign. I can multiply both sides by the same value and not upset the balance of life. If this was an expression, there is no both sides. So you have to have two sides of an equation in order to do this. Why are there two 4x's over here? Is it unbalanced? No, I'm just distributing. I'm saying I'm multiplying 4x to this side, distribute, and I'm multiplying 4x to this side. So because I have an equation, because of the equal sign, I'm going to multiply by the common denominator. Watch what's going to happen, all right? So a couple things here. Notice my 4x's appear to be slightly floating. I'm not multiplying by 4x over 4x. I am multiplying by 4x over 1. So there is a reason for that. I'm not multiplying top and bottom. This is not a top and bottom thing. This is a left and right sort of thing. Left and right side of my equation. What happens? Well, I had an x here, and I have an x here. X divided by x. Gone, gone. What am I left with? 6 times 4, otherwise known as 24. Oh, look, there's no more denominator there. Rejoice, destroying denominators. Excellent. Gotta love destruction. Next one, 4. 4. Multiplying by 4, dividing by 4. Multiplying by 4 and dividing by 4 will cancel each other out. Plus, keep my plus sign, what's left? 5 and x did not cancel. That's going to be 5x. Look, no more denominator. Destroying denominators. Keep the equal sign. What's going to happen here? Kind of the same thing as our last set. We are multiplying by 4. We are dividing by 4. Those guys are gone. That's going to be negative 7 times x or negative 7x. So if I have an equation, I can destroy the denominators by multiplying left and right by the least common denominator. What you have left is usually not terrifying. I'm just going to solve for x now, which means I'm probably going to subtract 5x because that seems like a good idea. So 24 equals, if I subtract 5x, that'll be a negative 12x. And then, divide both sides by negative 12, so negative 2 is equal to x. Yay. Did it occur to you? Did you even look? Do we have an extraneous solution? Is negative 2 good? Can we keep it, or do we have to toss it? What are we looking for again? You can't divide by 0. If negative 2 is x, is there any chance that we're going to end up dividing by 0? No. This is a perfectly acceptable solution. It's a keeper right there. All right. So let's look at something slightly different but similar, shall we? With this one, again, I spaced it out nicely, but I specifically chose something where, they're not all fraction looking. Is x still a fraction? You better believe it. It's x over 1. 3 is still a fraction. That's 3 over 1. This one just happens to be minus 18 over x, and this is a clearly visible fraction denominator that is not 1. So again, if I want to think about what is my least common denominator, why am I thinking about this? Because it's an equation. This has a denominator of 1, 1, x. Guess what my common denominator is going to be? I'm hoping you said x. Which means, again, I'm going to multiply both sides of my equation, both sides by x. So I'm going to distribute the x on this side. So I'm going to multiply this by x, and I'm going to multiply this by x. I can put a multiplication sign there if I want, I guess, and multiply this by x. Again, I'm multiplying by x over 1. I'm not multiplying top and bottom by x. I'm multiplying every term on both sides by x. What will happen? X times x. Nothing cancels. That's okay. X times x is x squared. This had no denominator. We weren't trying to get rid of a denominator. It's cool. Keep going. This was divided by x and times x. These guys will undo each other, so that becomes a minus 18. The x is canceled out, and equals, what's 3 times x? I'm guessing it's 3x. No more denominators. We have destroyed the denominators. We've multiplied both sides of the equation by the common denominator. And again, we're back to having something quadratic. So I'm going to go with what I was thinking before, and I'm going to consider setting it equal to 0. So that's going to be x squared. I'm going to subtract the 3x over here. I've already got the minus 18 equals 0. Yay, happiness. What about factoring? Factoring could work, right? Again, here, I just got x by itself because I only had the x squared. I had no other x. This still has the negative 3x, so I don't want to try to get x by itself here. That's a terrible idea. I could maybe use quadratic formula, but if I can factor, I want to do that. I'm less likely to make a mistake. I'm going to go with, I believe it's x plus 6 and x minus 3, and then I'm going to double check just to make sure I still agree with myself. Nope, I don't agree with myself. Switch the signs. Oh no, she made a mistake. That's life. It happens. If you don't like what you've done, change it, fix it, try something else. It's not the end of the world. So now I've got the plus and the minus and the... There we go. I like that much better. What does that mean? That means I have two answers here, hopefully, which is quadratic. Having two answers makes sense. 6 is going to be one of those, and -3 is the other. Oh no, there's two answers. I bet you we're going to cancel one of them out. One of them's got to be extraneous, because here we had two and we got rid of it. So this only had one answer. This only had one answer. Stop projecting what you think should happen onto a problem and let the math speak to you. What causes extraneous solutions? Dividing by 0. If x is 6, is there any chance I'm going to divide by 0? No. If x is -3, is there any chance I'm going to divide by 0? No. These are both answers. These are both correct. We are keeping them. No extraneous. We are only looking for things that might make the denominator equal to 0. All right. I have one last example for you, specifically because it is a doozy. Doozy's a good word. All right. So, what if, actually I don't need this paper. What if, there we go, life is more exciting? Now what? Now what? Now what? Maybe I'll leave this guy here. I didn't space him out yet because we need to do some pre-work here. These last two examples had pretty simple denominators, and so finding a common denominator was not a tragedy. This one is going to be more interesting. So I want to start by breathing, and then I'm going to take a look at my denominators. So x plus 1 cannot be factored. Therefore, x plus 1 is a factor. Just going to rewrite it so I can see it. X squared plus 2x plus 1 can be factored. What is it? It's x plus 1 times x plus 1. How do I know that? Because I've been doing this a long time. You need to get a whole bunch of practice to be good at factoring. I'm going to write this as x plus 1 squared. Some of you are thinking, hey, that's not the same thing. Yes, it is, because if you're going to square this, you need to FOIL. Distributing powers is not a thing. It's not. 9, what is 9? If I think prime numbers, 9 is 3 squared, so there we go. So this idea of least common denominator, again, from one of my previous videos, I want to put together the highest power of every factor. How many factors do you see here? I see 2. X plus 1 is a factor, and 3 is a factor. What's the highest power of each? Well, I've got x plus 1 to the first and x plus 1 to the second. X plus 1 to the second. This one's going along for the ride. That's part of my least common denominator. And then I have a 3 squared. Well, I have no other 3's, and every factor's got to be represented, so there we go. 3 squared is also going to be part of my common denominator. All right, so now, giving myself some space. I've got, I think I can do this. We're going to go with a 3 over x plus 1. That's enough space, I think. Plus 10 over, I'm just going to rewrite this as x plus 1 squared, because this is the same thing. I'm going to do that to conserve space and also to show what's going on. And then equals 7 over 9. All right. So think about what we just said our common denominator was. Because it's an equation, because of the equal sign, we're going to multiply every term on both sides, distributing all the way through, by the common denominator, which is 3 squared, otherwise known as 9, times x plus 1 squared. Again, distribute times 9 times x plus 1 squared times 9 times x plus 1 squared. That is my least common denominator. I'm multiplying it by every single term on both sides of the equation. Again, I did not put anything here. We're not multiplying top and bottom. That's not the balance we're going for at the moment. This is over 1. If you need to write the over 1, then you write the over 1. Okay? It's going to work like these guys, though. We're looking for now things that might cancel, because if we've done this correctly, all of our denominators should go away, and then we will have a happier life. At least that's what they tell me. This is an x plus 1 factor, and this has x plus 1 squared. That means that there's 2 factors of x plus 1 here. So one of these x plus 1's will cancel with one of these x plus 1's. So there were 2 factors of x plus 1. One of them cancels. One is left behind. So what do I have here? 3 times 9 times x plus 1. 3 times 9 times x plus 1. I'm going to write that as 3 times 9 is 27 times x plus 1. All right, so just little steps here at a time. Next one up. This one is divided by x plus 1 quantity squared times x plus 1 quantity squared. Both factors here cancel with both factors here, leaving me with 10 times 9, otherwise known as 90, equals 9. Dividing by 9, multiplying by 9. 9 cancels with 9, leaving me with 7 times, neither one of these x plus 1 factors canceled, so they are both still here. I have no more denominators. I have destroyed my denominators. Now I just need a little bit of patience to work with the rest of this. It's quadratic again. In case you haven't noticed, you have to be able to solve quadratic equations pretty much as easily as you can breathe. At least there shouldn't be scariness involved. So I'm going to start, let's distribute. That's going to be 27x plus 27, and that's plus 90, and that equals 7. I'm going to hold the 7 aside for the moment, and I'm going to go ahead and FOIL this. Do not distribute the exponent. Rar, that's bad. But x plus 1 times x plus 1 would be x squared plus 2x plus 1. And to do a little bit of cleanup here on aisle 4, that's 27x, 27 plus 90, those are like terms, so that's going to be 117, I do believe, is equal to, I'm going to distribute this 7, so that's 7x squared plus 14x plus 7, okay, actually I don't need that there, why did I write it? And let's still keep working towards setting an equal to 0, because oftentimes that is a helpful thing for quadratics. So I'm going to push these guys this direction. So 0 is equal to, I still have a 7x squared. There's no other like terms for that. I'm going to subtract 27x on both sides, giving me a minus 13x. And I'm going to subtract 117, so that's minus 110. All right. Those are big numbers. Nobody likes those numbers. That's okay. We can do this. I'm gonna factor anyways. I'm gonna go out on a limb. I think it factors. Could I use quadratic formula? Yes, I could. I'm gonna go with, it's gonna have to be 7x and x, because those are the only two things that multiply to make 7x squared. Things that multiply to make 110. If I think maybe 10 times 11, but I need a 13 for the middle. That's not super useful. What else goes into this? 5 times 22. Ooh. 5, 22. Check my OI for foiling. Outer is 35, inner is 22. 35 and 22, we can make the 13 there. We can do this. So we need to do a minus 35 and a positive 22. There we go. That actually factored. Which means if I set my factors equal to 0 and finish this off, I find out that x is equal to what? What is x equal to? This is going to be subtract 22 divided by 7, negative 22 sevenths, because everybody wants an answer of negative 22 sevenths. And then the other option is 5. All right, well that's cool. Did you think about it? Did you look? Did it even cross your mind? Do we get to keep both of these? Is anything here extraneous? Do we need to throw something out or not? Well, I cannot have my denominator equal to 0. The only thing that's going to make that up here is a negative 1. Neither one of these is a negative 1. I get to keep them both. Do I need to keep checking for extraneous solutions, even though out of the 4 examples, only one of them had an extraneous solution? Yes, you should keep checking. You should always check. It doesn't take that long to check. Just saying, hey, will my denominator be 0 or not? That's it, guys. This is essentially, I don't know, a giant pain in the butt, but it is possible. You're solving linear stuff sometimes, you're solving quadratic stuff sometimes, but the big thing is knowing that you have an equation and what your strategy is going to be as a result of that. Okay? Practice, find support, get help. Enjoy.